In this lesson, we're going to look at the last of the algorithms for this chapter, and that's the binary search algorithm for searching for an element in a sorted collection, such as an array. And it's very important that the collection or array be sorted before the binary search algorithm is applied, because it won't work if the elements are not sorted. So let's go ahead and get started. I've already written part of the program here, so let's go over that real quick. We have a display method for displaying the elements of our array, so we can look at them after they're generated. In fact, we need to add that into our program right here. After they're sorted, we need to display them. And then, of course, I've generated an array full of random numbers, 100 numbers to be exact, 0 through 99 in the array. And we use the math_random method to generate random numbers. And then we prompt the user to enter a number to search for. And at that point, we're ready to call the binary search algorithm, so we need to go ahead and implement that. So we'll start it right here. We return an integer because it's going to return the index position in the array where it finds the element being searched for, or it's going to return -1. Key is the value that we're searching for. So the first thing we do is we set up a couple of variables. First is the lower bound of the array. Last is the upper bound of the array, which is the length of the array -1. Then we have a while loop that says while first is less than or equal to last. And the first thing we do is calculate a midpoint, first plus last divided by 2. That'll be the middle element of the array. Then we say if the key that we're looking for is greater than the element that's at the midpoint, then adjust the first of our array, or in other words, move up to the top half of the array. So now the first of the array becomes the midpoint plus 1. Otherwise, else if the key is less than the midpoint, then adjust the last down. In other words, move to the bottom half of the array by making the last element the midpoint -1. If neither of those situations are true, then we've obviously found the element, so we return the midpoint. Finish off the while loop, and then if we go all the way through the loop and haven't returned the midpoint, then we never found the element, so we return -1 to indicate the element wasn't found. What we'll do here is we'll say int found equals binary search, numbers is our array, num is the element that we're searching for. Then we can say if found is greater than or equal to 0, found key at position plus found, else key not found. Making sure I have all my closing braces in order. Looks like I do. So let's save it. Go back to our command prompt, clear the screen, compile again, and run the code. Here are our elements. Let's look for one that's in the middle of the pack. Notice we have some duplicates, and we forgot to do a new line there, but that's okay. So we'll do 36. And found key at position 45, which is right about in the middle. Let's run it again. We're not going to worry about any of our little discrepancies in formatting. Let's look for one that's close to the end, 98. Found 98 at position 98. That's fine. Do it one more time. Let's search for 3. That's right, found it at position 1. Clear the screen. Run it again. Let's try 19. 19 is not there, and key not found. So that's how the binary search algorithm is implemented. And with that, we're ready to move on to the exercises for this chapter.